Hi guys, welcome back. We're going to talk more today about the Excel add-in for thermodynamic calculations, particularly the DWsim suite. Okay, so in our last video, we talked about installing the suite along with solver and some VBA tools. However, we want to correct some mistakes made in the last video. In the last video, I actually talked about bringing the DWsim files onto the desktop and adding them into Excel. Apparently, it shouldn't be this way. That's not the correct way of installation. So we want to just sort that out for now. Okay, that's our first thing. And of course, after that, we want to talk more about some of the functions in this DWsim package in Excel. Alright, so for the installation methods, first step, of course, as I'm highlighting here, you have to install the Excel add-in by installing the DWsim software package, meaning to say you install the free version of HiSys first. And remember the location where DWsim was installed. So you use this location to add in the XLL file. So what do I mean by that? Okay, let me just close this. Ignore all what you have seen first. So we have this DWsim shortcut on the desktop. All you have to do is open the file location as before. And now you will see this DWsim folder, and you just look for the DWsim64 or DWsim. So this is the add-in. This DWsim is the add-in you want to find, and preferably you have to do that by going to the add-ins, to the add-in manager, and you press browse, you click browse, and you should go to app data, local. That's where I installed it anyway. So you just take note where you put the DWsim is in add data local, that's my name, and this is DWsim 5. So app data local DWsim 5, this is where it will be, and just click this DWsim, that's the correct one. Press OK. Now if of course you have already installed it correctly, you will need to do this step. But if somehow the system isn't working, the add-on isn't working, you should be doing this just to set the DWsim correctly. Set and install the DWsim correctly. So just press yes, and if it's installed correctly, you should be seeing this DWsim tab as well as these options over here. I hope that clears things up. If you have any questions, please post it in the comments. And of course, I have the proper websites over here, which I will post in the description. And one more thing, before you even are able to browse for the correct DWsim folder, you'll have to do something first, and that is to display the hidden files and folders. Because by default, the DWsim data files in the app data, it is a hidden folder. So what you must do first is to go to the files and folders. Get the settings. Okay, so never mind. Control panel first, and sorry, never mind. Files and folders. So first thing first, you have to go to the files and folders. When you just press search files and folders in the control panel, make sure in the navigation pane you should be clicking show all folders and show libraries. If not, you won't be able to find your DWsim files. So make sure that these two checkboxes are ticked in order that you may find your DWsim files. And of course, you should be clicking this show hidden files, folders and drives. And yeah, I also put always show menus just in case, but just make sure the bottom three are checked, and generally you should be able to find your DWsim file and install it correctly. So are there any other instructions there? Yep. So moving on, yeah, they say after installing DWsim, open Excel and go to file, which is just what we have done just now using the manage Excel add-ins. and look for DWsim.xll. For my version, the DWsim XLL will work just fine, so that's a 32-bit XL version. So we're just going to keep it as that. Now to the more interesting part. Recognize that, well, DWsim has a lot of functions. Now, where do you find that? Okay, so first thing you do, click on this part, insert function. Okay, so you'll be by default on one of these tabs. Go all the way to the bottom, you'll find the DWsim category. So at the DWsim category, you will find lots of functions. And among these functions are calculation of properties, getting a compound list, blah blah blah. It may seem very confusing at first. So don't worry, I'm here to, get you through the messy part. So for this video, I want to introduce some function. And let's say we have a scenario where you want to do a flash type calculation. Now the question is how? So this is just learning by doing. Okay? So let's work backwards. We begin with the end in mind. Begin with the end in mind. Meaning to say, okay, at the end of the day, I want a flash calculation. So how do we do a flash calculation? So first thing, go to FX. We go to FX and we look for these flashes. These are the flash calculations I was talking about. Alright. So how do these actually work? If you're not sure, you can start looking at the help folder where there's more data. Okay. So this is the help folder. Alright, so help folder is in this tab, DWsim, help folder is here. And you can go to flash calculations. So there are lots of flash calculations. Which one do you want to use first? Well, let's take a look at the first one. It's called PT flash. It says it will calculate a pressure temperature flash using the selected property package. Basically what it means is this. You have a hypothetical flash drum, an ideal flash drum, and you fix the pressure and the temperature so that whatever components are going in are going to have a fixed temperature and pressure, and therefore everything else will be fixed in that vapor liquid equilibrium. Yep. So okay. So these are the inputs and these are the inputs you'll need to put in. A big bunch of mess again, but don't worry. I just copy and paste it in the main file, which is over here. So from the help folder, I copied and pasted all these files here. So these are the various inputs that you'll need to put in the DWsim. So for example, you need to specify the temperature and pressure, as well as the compounds, the mole fractions, and the calculation algorithm you will use to get your flash calculations. Okay, it's a very messy thing, but let's make it more simple. I'm pretty sure you should understand pressure and temperature, compounds, and mole fractions quite intuitively if you studied chemical engineering kind of long enough. However, the more interesting ones will be this flash algorithm and the property pack, as well as this interaction parameter. Now, let me first say that you can ignore these interaction parameters first, because these are for, if you're really familiar with thermodynamics and you have, your own experimental data, you can go and set the own interaction parameters for fugacity calculations and activity coefficient calculations. So for now, we don't deal with this because we don't really need it at all, okay? It's for the demonstration purposes first. So first thing first, we want to talk about the property packages and the flash algorithm. And of course, if you're not sure what the inputs are in a function, we can take a simple function, let's say a plus b equals c. So this function, what the inputs are a and b. So adding them together, it gives you c. So these are the inputs and outputs. So we want to move on to a more complicated function. Let's say A is a function of B, C, D, E, and G. So the input will be A. Oh wait, no, the input will be B, C, D, E, and G, and the output is A. Okay, the output is A. And of course, in our function, especially for this flash drum system, we have lots of components. We want to find out what's in the liquid phase, what's in the vapor phase, and that is a function of all the function of the pressure and temperature of the flash drum, as well as the mole fractions of the components going into the flash drum. So not only that, it has to be dependent on what kind of fluid package you actually select. Alright, so whether it's Peng Robinson NRTL or some other kind of fluid package. Well, I'm not going to talk about how you select it in this video. Okay, not in detail, but just want to tell you that different fluid packages will give you different results, and some fluid packages are fitting to your system more than others, and this is a thermodynamics kind of a concept. And yeah, if you're not sure, you can look at Carlson's or Cedars to help you decide which kind of fluid package. And for our example here, we want to have a water methanol system with some hydrogen, this is syngas, yeah, syngas, water, methanol, and some syngas with a bit of nitrogen. So which fluid package are we selecting? For this, we want to take for this simulation, we know that it's less than 10 bar, yada 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 yada. Then the Carlson's recommendation is for us to use NRTL. Well, basic concept is that, hey, it's a very low pressure system, so the gas can be, more or less ideal, assumed to be ideal. But in the liquid phase, you have non-ideal mixing because there's water and methanol. And as this results in the liquid mixture being highly polar, and therefore there's lots of non-ideality. So NRTL has to be used to calculate the liquid phase coefficients for the fugacities. Okay, so that's just some background. So property package, for this case, we do want to take NRTL. I briefly explain why, and this is the flash algorithms. If you're not sure what the flash algorithms are, let's go to the help file, the website, which talks about the Excel add-in. This is the DWsim homepage, and we'll go down to the flash algorithm and results validation part of the wiki. So we have a few algorithms, nested loops. Nested loops are the default ones. This is for normal vapor-liquid equilibrium, VLE systems. There are nested loops for vapor-liquid-liquid equilibrium, meaning to say, like, you have the methanol, MIBK water and acetone system, where you have a few phases of liquids, or maybe 2 phases of liquids, maybe in equilibrium with a vapor. You might want to use these. Okay, inside out, 2 or 3 phase for petroleum. This one is for this Gibbs minimization for highly ideal non-chemical systems. You can read the rest here. We even have eutectic solid systems and solid solution systems. So obviously our water methanol system is none of all those things, so we shall use nested loops for our vapor liquid equilibrium. So now we have more or less had a good idea of what the inputs are going to be in this scenario. We want to see how we actually obtain those inputs. Get some water first. Okay. So anyway, these are just some websites for you to talk about the fluid packages. And first thing first, we will need to find what the property package is. So how do we get this property package? Because you have to put this as an input into your PT flash calculations. Okay, PT PT flash calculation. So you have to, let's say we have this cell, we want to have the PT flash calculations. You can put insert function, and we go to PT flash, which is the most basic. So we start with the easiest, PT flash, pressure temperature flash. So they'll be asking you for property packs, flash algorithm, PT compounds here, and etc. These are the interaction parameters. For this, we're just going to leave it blank. So how are we going to fill it in? Now let's walk you through. First thing you need is a property pack. What is a property pack? Well, we haven't been introduced to that yet. So let's look in the help file for a property pack list. So just nice, in the help file, there's a link. You can click to the property pack list. So let's go there. So when we click on the link, you go to this help file. It says get prop pack list. This is a function which helps to return a list of available property packages, meaning like whatever this is, all these things here. There'll be Ping Robinson, Soaf, Ricklich Kwong, and etc. So let me demonstrate to you how to get it first. So after we get our property packages, we use one of them as the input. Okay, so you have done with this part, which property package. So just ignore this first. So let's say you want to get a property pack. So let's select a blank cell. Let's say K87. So this is 87, this is K. So I'll just select this for this cell here. So equals get prop pack list. So just click on this here. Okay, and of course for this case we do not need any inputs, because this will just give us the names of the property packages. So just press enter and you will get this cool prop, like cool properties, right? However, the thing is, with this we have more than one property package, right? So we don't just want cool prop, we have Ping Robinson and all that. In fact, if you do it correctly, if you do it correctly, you should have a list like NRTL, Uniquac, Unifac, Ping Robinson, I don't know how to pronounce it properly, PRSV2, etc, etc. You will even have sour water systems in here, and steam tables. So it's a pretty extensive suite of packages you can choose from. Okay, and of course if you want all these packages, you have to make sure it is installed during the installation phase, meaning to say you should just install all the extra add-ons that they ask you to install, provided of course they are not like virus or anything like that. So far I haven't encountered anything like that, so don't have to worry. So anyway, how do you get this long list of property packages? Well, in this case, all these have to do with something called arrays in Excel. Now, if you're not familiar with arrays, let me just run you through quickly. Okay, that's for later. So again, we have this get property pack list. So let's put it here. Put it here in G91. So this G91, cell G91. Alright, so we want something like this. We can't just drag it down, you just have the same cool prop, right? So you want the cool prop, Ping Robinson and everything. So what you do, select this, use a mouse, click on this cell, then scroll down and click on this cell. Okay, I was pressing the shift button. So again, click this cell and then we shift click on G109. So that's how you edit arrays. So once you do that, click here, or you can press F2 to ensure you're editing the first cell, G91. Then what you do to apply the array is do something called Control, Shift and Enter. And now that will give you all of the property packages. Alright. So that's why I labeled this Control-Shift-Enter. Okay, so that's just to demonstrate for you. However, the thing is that, of course, you cannot. Okay, it's lagging. You cannot change any parts of an array. So that's the thing. Once you have an array, you can't edit it. So let's say what happens if you want to delete. What happens if you want to delete this array? So simple thing, select everything, shift click, and all you have to do is delete this formula, delete, alright, and Control-Shift-Enter. Now Control-Shift-Enter will delete the whole array for you. Okay? So yeah, that's okay, part 1 of this introduction. I'm sorry I'm running a bit, I'm being a bit long-winded, but yeah, that's how we can do the first steps of, you know, doing this TP Flash. Alright? Okay, so see you in the next video. I'll tell you more about how to get it done right. See ya!